Hi there, grade 10. I'm going to discuss trigonometric functions and quadrantal angles. The study of trigonometry covers the six trigonometric functions which will be defined in our discussion. To define these functions, we start with an angle theta in standard position, and then we're going to choose any point P on the terminal side, any point except the vertex of angle theta, and we will name the coordinates of P equal to xy. Now in the figure, PQ is perpendicular to the axis that determines a right angle with vertices P, Q, and O. Now, we can find the distance here using the distance formula by considering point P and the origin. So, we come up with R equals x squared, square root of x squared plus y squared. Take note that R here should be equal to 0 since distance is never negative. Now, the six trigonometric functions of angle are sine, cosine, tangent, cotangent, cosecant, and secant. So we will be able to identify the ratio here, which are sine. So this is sine theta equals y over r. Cosine theta equals x over r. Secant theta equals y over x. And cotangent theta equals x over y. The ratio of each trigonometric function can be also derived using the acronym SOHCAHTOA. S stands for sine, C for cosine, and T for tangent. Now, the other three will be derived from each of these three since the reciprocal of sine is cosecant. We'll just get the reciprocal of sine theta. That will be cosecant theta. So that's why we have y over r here. And cosecant theta becomes r over y. Likewise, cosine theta equals x over r. So its reciprocal function, secant theta, will be y over x. So the reciprocal. And then tangent y over x. For cotangent, this becomes x over y. Now, this SOHCAHTOA that I was referring defines the ratio of each trigonometric function. So when we say so, this is opposite over hypotenuse. So this is your theta. And opposite side of this theta is y, and the hypotenuse is the opposite side of the right angle, which is r. So we have y over r. Now for cosine, so that's ka. So what is the adjacent side of this angle theta? We have x and r. We will not consider the longest side, so the adjacent side will be x over hypotenuse. So that's ka, adjacent hypotenuse. So that's why we have x over r for cosine. And then TOA, T would mean tangent. And then opposite side of this is y. And then the adjacent side is x. So that's why we have y over x. So we got the ratio of each trigonometric function value here by considering also the acronym SOHCAHTOA. Now, we will be working on finding the 6 trigonometric function values of an angle theta. For instance, the terminal side of an angle in standard position passes through the point 815. So this is the terminal side of angle theta, and this passes through 815. So this is 815. Find the values of the 6 trigonometric functions of angle theta. So we know what is x and y. So how did we come up with r equals 17 here? So solving for r is obtained by working on, since r is equal to square root on x squared plus y squared, and we know that x is 8 and y is 15. So substituting the given in the formula, we have 8 squared plus 15 squared. So we have 64 plus 225. We have square root of 289. And we know that square root of 289 is 17. So therefore, r equals 17. So we can now find the values of the 6 trigonometric functions. So we know that sine theta is y over r. So sine theta is 15 over 17. So its reciprocal function cosecant theta is equal to 17 over 15. Now cosine theta is x over r. So x equals 8 and r is 17. So this is our cosine theta. So secant theta is equal to the reciprocal of 8 over 17. We have 17 over 8. Now tangent theta is y over x. So this is equal to 15 over 8. On the other hand, its reciprocal function, cotangent theta, equals 8 over 15. So these are the 6 trigonometric function values. Okay. In number 2, it's still finding the function values. Okay. So the terminal side of an angle theta in standard position passes through the point -3, -4. Find the values of the 6 trigonometric functions of angle theta. This time, class, the terminal side will lie on the third quadrant since the coordinates of the point are both negative. So as you can see in the figure, so this is the terminal side and this is point P, -3, -4. Now, the value of r is, again, r equals x square root of x squared plus y squared. So we have quantity -3 squared plus quantity -4 squared. So we have 9 plus 16. So this is 25. So this is 5. So r equals 5. So sine theta is y over r. So your sine theta is, so here x is -3, y is -4. So it's -4 all over 5. So -4/5. While its reciprocal function cosecant theta is just the reciprocal of sine theta. So this is -5/4. Cosine theta, again, is x over r. So x is negative 4 while y is r. So this is negative, rather x is negative 3 and 5 is r. So it's negative 3/5. And its reciprocal function secant theta equals the reciprocal of cosine theta, which is negative 5/3. Now, for tangent theta, it's y over x. So this is negative 4 all over negative 3. So this is positive 4/3 now, while its cotangent function is 3/4. Now, take note that if the terminal side of angle theta lies on quadrant 1, so all trigonometric function values are positive. While if the terminal side of an angle theta lies on the second quadrant, we're expecting that sine theta and its reciprocal cosecant theta are positive. The rest are negative. So here, tangent theta and cotangent theta are positive. The rest are negative. So in our second example, terminal side lies on the third quadrant. And really, the values of tangent and cotangent theta are greater than 0 or positive. Now, lastly, if the terminal side lies on the fourth quadrant, cosine theta and secant theta would have a positive value. The rest will have a negative value. So, in number 3, finding the function values of an angle. Find the 6 trigonometric function values of the angle theta in standard position if the terminal side of angle theta is defined by an equation. So this is defined by an equation. No points were given, but we're given an equation of the terminal side. So defined by this equation. So if we're going to select 2, -1, which lies on the terminal side and the corresponding value of r. So how did we get this 2, -1? So if we're going to select, the condition here is x is greater than or equal to 0. So we are restricted to select values of x which are from 1 to infinity. So we are not going to consider 0. Instead, we're going to consider 1 up to positive infinity since the terminal side lies on the fourth quadrant. Okay? Now, if we select x equals to, as illustrated here and here also, if x is 2, we will substitute x equals to the equation of the terminal side. So we have 2 plus 2y equals 0. Now, transposing the constant term on the other side, we have 2y equals -2. And dividing both sides by 2, we can solve for y. And y is -1. So we have a point on the terminal side, which is 2, -1, which is this one. So the point 2, -1 lies on the terminal side, and the corresponding value of r is, so we know that r is square root of x squared plus y squared. Substituting x and y here, we got square root of 5. So this is our r. So we use the definitions of the trigonometric functions. So we can solve for sine theta. So sine theta again is y over r. So sine theta is negative 1 square root of 5. Of course, simplifying this, rationalizing the denominator, we have negative square root of 5 over 5. And its reciprocal function, cosecant theta, is equal to the reciprocal of this. So we have negative square root of 5. For cosine theta, it's x over r. So x is 2 and we have square root of 5. So simplifying 2 all over square root of 5 is done by multiplying both sides by square root of 5. So we have 2 square root of 5 all over 5 as cosine theta. And its reciprocal will be secant theta. So reciprocal of 2 all over square root of 5 will be square root of 5 all over 2. Take note, class, that cosine theta and secant theta are positive since the terminal side lies on the fourth quadrant. And the rest will be negative. So for tangent theta is y all over r or all over x. So we have y all over x. So we have negative 1 all over 2. So this is negative 1 half. While its reciprocal function, cotangent theta, so this is x over y. So we have negative 2. Now, how about quadrantal angles? Quadrantal angles, class, are angles in standard position with terminal sides lie along either the x or the y axis. So, meaning, if this is the initial side, so this is one quadrantal angle because the terminal side lies along the y-axis. Another quadrantal angle is this one, quadrantal angle. So the terminal side lies along the x-axis. Okay? Now find the values of the 6 trigonometric functions of each angle. An angle of 90 degrees. So first we select any part on the terminal side of an angle theta. So for instance, here, so this is 90 degree. This is the terminal side of a 90-degree angle. Okay? And this is the initial side. And this 90-degree angle is in standard form since the initial side lies along the positive x-axis. And this is considered as quadrantal angle since the terminal side lies on the y-axis. Now we're going to select any point on its terminal side. Of course, we're going to consider the lower value of x and y. So we can select x1 and rather 0, 1. So if the point that we selected is 0, 1, it follows that x is equal to 0 and y equals 1. So r here is equal to 1 as well using the formula for r. This is 0 squared plus 1 squared, right? So this is 1. Now, sine 90 degrees is y over r. So we have 1. As well as cosecant, cosecant 90 equals 1. That's r over y, right? Now, cosine 90, on the other hand, is x over r. So this is 0. And its reciprocal function, secant 90, is r over x. This time, x is 0 and x is the denominator. So we will be leading to undefined value for secant 90. Now, tangent 90 is y over x. So we have 1 over 0. So this is again undefined. And then cotangent 90 is x over y. So this gives us 0. Okay? So these are the 6 trigonometric function values when theta is 90. Now, an angle in standard position with terminal side passes through negative 30. Okay? So, in here, x is negative 3 while y is 0. So, your r must be quantity negative 3 squared plus 0 squared. So, this is square root of 9. So, r is 3. So, sine theta is y over r. So, we have negative 1. That is, sorry, y over r is 0 over 3. So, that's 0 rather. So, again, sine theta is y all over r. Okay? So, we have y here equal to 0 and r is 3. So, this is 0. So, for cosecant theta, this is r over y. So, this will be undefined. For cosine theta, so this is x over r. So, this is negative 3 all over 3. So, we have negative 1. Likewise, for secant theta, this will remain negative 1. For tangent theta, we have y all over x. So that's 0 all over negative 3. So that gives you 0. But cotangent theta is undefined because y is the denominator and y is 0. Now, what have you noticed as regards to the value of quadrantal angles, trigonometric function values of quadrantal angles? We have undefined function values whenever theta is quadrantal angle. So if the terminal side of a quadrantal angle lies along the y-axis, then tangent and secant functions are undefined. So in our previous example, we evaluated trigonometric function values of theta equals 90, where the terminal side of theta equals 90 lies along the positive y-axis. So with that, tangent 90 and secant 90 are undefined. On the other hand, if it lies along the x-axis, the cotangent and the cosecant functions will be undefined. Now, the function values of the most commonly used quadrantal angles, 0, 90, 180, 270, 360, are summarized here. Okay, so The usual values of trigonometric function values of quadrantal angles are 1, -1, 0, and undefined. Okay? And quadrantal angles are multiples of 90-degree angles. So I hope you are able to understand the idea of trigonometric function values and quadrantal angles.